Hello and welcome back to the sixth part in the Introduction to Calculus series. Today we're going to be talking about the second derivative. So first of all, what is the second derivative? Now you might have already guessed that the second derivative of a function is just the derivative of the regular derivative. So if say we have a function x squared, then its first derivative, that's easy enough to find, that's going to be 2x, 2 jumps down, the exponent becomes a 1, and then the second derivative is just a derivative of this one. So that's denoted with 2 apostrophes like that, and actually you can have the third derivative, then you have 3 apostrophes, etc., but that one's not too useful. But the second derivative of 2x, that's just 2, right? So the second derivative, right, it's easy enough to compute. But what is it actually used for? Well, in the previous part we saw how to arithmetically or algebraically rather find minimum and maximum values of a function. So say we have something like this. So this is our x and y plane, x and y, and we'd have like a function, for example, like this. Then we would have a way to find these points. Like this is a maximum and this is a minimum. So I'll just quickly denote that, max and min. If you need a refresher on this, I'm pretty sure it's part 5 where I covered this, the previous part. And we would find the x values of these points by solving the equation. The derivative of this function is equal to 0, and that kind of corresponds to the fact that the tangent line to the graph is horizontal at a minimum or maximum. But in the previous part, I kind of left it on an uncertain note, like we weren't sure how to derive whether a point that we found was a maximum or a minimum just by the algebra alone. We had to plot the function and visually see whether the function, whether it was a maximum or a minimum. But actually, the second derivative can help us out with that. So let's actually do a bit of a plot of these 3 functions and see what they can tell us. Well, first of all, the regular function, that's going to be like that. So that's just x squared. And we can see this has a minimum right there. Alright, then the first derivative, that's 2x. It's going to be just a regular line like that. And we can see that this has a minimum for x equals 0 because the derivative crosses the x-axis at x equals 0. So that corresponds with solving this equation, right? Alright, and then the second derivative will be something, will be something like this. This is just a horizontal line, y equals 2, right? So this is the first, this is the, or rather this is kind of the 0th derivative, if you will, the first derivative, and then the second. So here we have a kind of all positive second derivative, and I want to look at another example just to make it clear what the second derivative can actually tell us. Alright, so another example is going to be in red here, negative x squared. Now this is easy enough, it's just exactly the same, but just flipped over, right? So it's going to have a maximum right there, and then derivative will be negative 2x. That's sloping down like that, again crossing the x-axis where the original graph has a maximum, and then the second derivative will be all like that, an all negative line, horizontal line, negative 2. And actually the second derivative here tells us whether it will be a maximum or a minimum. And it does that in the following way. Whenever you have a positive second derivative, like we had for the x squared case, because it was all positive, right? And it was positive at the x value where we had a maximum, or minimum rather. Then you'll get a minimum. And when you have a negative second derivative, that will give you a maximum. And when you have actually a second derivative equal to 0, that's gonna give you something whole different, but we'll cover that in another video. It's called an inflection point, but you don't have to know that for now. Just know that you can work out whether your critical point or your extreme point is a minimum or a maximum by computing the second derivative. So a positive second derivative corresponds with a minimum, a negative second derivative corresponds with a maximum. Alright, we'll finish off with a quick example. So we'll find the maxima or minima, well, we'll find out really, of the following function, x squared minus 1, all times x plus 1. So I'm not sure, pretty sure it does have extreme values, but we'll find out whether they're maxima or minima, what the points are, we'll see. Alright, so I'll quickly start by rewriting the function by just multiplying this out, right? Like that, so that's going to be x cubed minus x to that, x squared plus 1, that's just going to give us x squared, and then negative 1 times 1, negative 1. So quickly rewrite that like so. Alright, so now we'll just do the derivative, that's easy enough. The derivative, that's going to be 3x squared plus 2x minus 1. Alright, and now to find the critical points, we'll set that equal to 0 and solve with the quadratic formula. So take this term, square it, negative 4 times negative 1 times 3, like that. So that's going to be 4 plus 4 times 3. That's actually going to give us 16. How nice. Alright, now I just plug it in. That's going to be 4 plus or minus negative 2 divided by 6. I'll quickly move down a little bit. Split those up. Negative 2 minus 4, that's going to give us negative 6. Divided by 6 is just negative 1. And then the other one, negative 2 plus 4, that's just 2. So that's going to give us 1/3. Alright, so now we have our x values for the extreme points, right? So it's something like this. So we have negative 1 and then 1/3. It's always nice to make a little sketch to keep track of what you're doing. Always recommend that. Right, so now what we want to do, because I sketched it here as a maximum, but it doesn't necessarily have to be, I don't really know. So now we have to find the second derivative and then plug these values in to see whether they're maxima or minima. So the second derivative, that's the first term, 3x squared, that's, well, the 2 is going to move down, so we'll get 6x, and then 2x, that's just going to be 2, and obviously the negative 1, they'll go away. Alright, 6x squared, so we'll plug it in. First of all, negative 1, negative 1 plus 2, that's going to be negative 4, and then the second one, third, 6 times a third plus 2, that's just going to give us 4. Alright, so now we can look quickly up here. So we know that if the second derivative is positive, we have a minimum, which we have here, so this is a minimum. And if it's negative, we'll have a maximum. Maximum like that. So this one's a maximum, this one's a minimum, and it's actually the way I drew it. So like that. Alright, that wraps up today's episode. I'll see you in the next part. Bye bye.